Shalom to you and welcome. In this video, we will learn how to use the converse of the Pythagorean theorem. It says that if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So if we are given three sides of a triangle, we can use them to, like this, three numbers. Okay, we can identify the longest side and use that to check to see if that triangle is a right triangle. And this theorem has also like three parts. So from your book, see that? Okay, this is the main theorem there. Sorry. Theorem A3. Given a triangle, there is no sign here that shows us whether or not this is a right triangle. But if we consider that this the longest side, is the square of the longest side is equal to the square of the other two, then it is a right triangle. If the square of the longest side is less than the square of the sum of the square of the other legs, then it means that the triangle is an acute triangle because C should be the largest. So if C is less than 90, then every one of them is acute. Then on the other hand, if the square of C, the longest side, is greater than the sum of the square of the other two, then that triangle is acute and obtuse, and that obtuse angle is going to be at C. Okay, so those three. So we're going to test, even here in the problem, tell whether a triangle with the given side is acute, right, or obtuse. So we need to first of all find which one is the longest. So like this one is with square roots. You can't really tell what it is unless you simplify it. So I'm going to plug that into our calculator. So that's 8 times the square root of 3. And then hit enter. So that gives us 13.856. So this is equivalent to 13.85, keep going. So which is the medium. So this is the hypotenuse because it's the largest. So if that is the largest, then we make it 16 square is equal to 8 square. We are asking the question, put a question mark because we don't know yet. We are trying to find that out. Does it equal the square of this times 8 square root of 3 squared? Okay, and then we work our way all the way, simplify everything. Try 16 squared. 16 squared is 256. So this is 256 is equal to 8 times 8 is 64. That's 8 squared. And then plus, and then this one, just like we did in the other one, 8 times 8, this is going to distribute that. This is 8 times 8 is 64 also. And then this square root crosses out this. It's going to be times 3. Okay, again, if you don't remember from the last video, you can expand this to find out how this came about. So this square root is going to be distributed because this is multiplication. This is 8 times. Okay, and we can multiply, put them in parentheses, simplify that first. So 64 times 3 is 192. Is 192. So 192 plus 64. 192 plus 64, 256. It came together to be 256. Okay, and this our left hand is still 256. So that check, they are equal. So that means the triangle with these sides is a right triangle. Okay, so we just write that it is a right triangle. Because using Pythagorean theorem, the proof. Let's look at another one. Here we have 8, 14, 17. We can see right away that 17 is the largest. So 17 is going to be the hypotenuse. So again, the two legs will be on one side. So 8 squared plus 14 squared. We always add the square of the two legs. And then the hypotenuse square is by itself on one side. So make sure you keep that order. Then we plug things into our calculator. So of course 8 times 8 is 64. And then 14 squared, or 14 times 14, 196. And then 17 squared, or 17 times 17, can put it that way, 289. Okay, this is 289. Okay, so now we add the left side. So 64 plus. Watch when you're adding and when you're multiplying. Okay, don't mix things up. This is 260. 260. By the way, we put our question mark there. Does it equal 289? So we say it does not equal. So we know it is not a right angle. It's not a right triangle. But the hypotenuse is greater. See, the hypotenuse is greater if the two legs, the sum of the two legs is smaller. So if the hypotenuse is greater, then that means it's going to be an obtuse triangle. So 289 is greater than 260. So it is obtuse. It is obtuse triangle. Okay. Let's do one more. So here, looks like this is an isosceles triangle because both two sides are equal. This is the hypotenuse because it's larger. So again, we do the hypotenuse squared equal to, okay, hold on. Okay, a little more. Okay, so hypotenuse square equals 11 square plus 11 square. Again, you have to square them before you add them. Don't make the mistake of adding them before you square. So, calculator work. So, 15 squared, 225. Does it equal 11 squared, which is 121. 121 plus 121. So 121 plus 121, 242. 242. So so we notice here the hypotenuse, you can always label the hypotenuse is not equal. So it's not a right triangle. So but the hypotenuse is less than the sum of the squares of two legs. So if it is less, this is going to be acute. It is an acute triangle. Okay, to be able to keep the order, if you would write the side of the hypotenuse first before the leg, so that way you won't make mistake with the inequality sign when it is not right. Okay. Let's do one with decimals. So sometimes it can be confusing to compare decimals to find which one is the biggest. So I encourage you line them up. So if I have 0.5, 1.2, and 1.3. Okay, you start from the right, go read from right to left. So we compare the right. You see this one is the smallest. So these two have 1, 1. Then you move on to the next. So this has 3. So this is the largest. So that's the hypotenuse. Once you identify your hypotenuse, the two legs doesn't matter as long as both of them go on the same side. So 1.3 squared, does it equal 0.5 squared plus 1.2 squared. Okay, then plug into the calculator. So 1.3 squared is 1.69. 1.69. Then 0.5 squared. 0.25. And then 1.2 squared. Oops, sorry, that's 1.2, not 144. Okay, 1.44. And then we add the right together. So 1.4 plus 0.25 gives us 1.69. And we have 1.69 on the right side, so they equal. If they equal, then it is a right triangle. Done.